Hello everybody, in this video we are going to solve another problem live from LeetCode's top interview 150 problem list. So far we have solved all the problems from top to zigzag conversion. If you haven't checked out my videos on those problems, please go to my channel and check them out. Today we are going to do the next one, which is find the index of the first occurrence in a string. Okay, so let's read the problem and make sure we understand it. Given two strings needle and haystack, return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. Yeah, this is a standard substring problem. Given string 1 and string 2, figure out where is the first occurrence of string 2 in string 1. And yeah, let's look at the examples. Haystack is sad but sad. The needle is sad. Then yeah, first occurrence of sad is at index 0, so we return index 0, right? And yeah, explanation is sad occurs at 0 and 6, but the first occurrence is at 0. Then haystack is LeetCode and needle is LeetO. Yeah, so LeetO is not in LeetCode, so it's -1. That makes sense. Okay, so the constraints are that the length of haystack and needle are between 1 and 10,000, and needle and haystack consist of only lowercase English characters. Yeah, I mean that second constraint is not really that helpful. We are just going to do exact match and yeah, that will handle all the characters, not just the lowercase English ones. So yeah, with that, let's figure out how to do this, right? I mean, it's a pretty straightforward algorithm. Let's say that if I know it's very straightforward, but just for completeness and just for hygiene, we should just run through the approach just once, right? Let's say haystack is sad, but sad as they have given, and needle is sad, right? So we just run in haystack from index 0. So how long is haystack? It's 9 characters. So the valid indices are 0 to 8, right? So we run from 0 to 5 because the 0 to 6 actually, sorry, and because the length of needle is 3, so we don't have to go all the way from 0 to 8. We can go from 0 to 6, which is 8 minus 3, and we check for each of those, right? So we say 0, 1, 2, 3, 4, 5, and 6, and in each of those indices, hey, is sad occurring at starting at 0? Here we will get true, but if it was a different string, we may not, and we keep on going until we find the first true, right? So if this was the first true, we return there, right? In this case, we would actually find it at index 0, right? Okay, so that's the approach. Very, very simple, straightforward. So let's first write a helper to actually check whether a needle occurs in haystack at a specific index, right? So let's call it has substring at index, I guess, string haystack and int index. I'm just going to make a little bit more space here. Okay, and string needle, right? And then we just say yeah, so I think what we want to do is we want to say for int I equal to 0, I is less than, remember, I is the iterator or index into needle, right? So I is less than needle dot length plus I, right? And we say if I'm going to take the length of the haystack string in a variable, final int hlen equal to haystack dot length. Okay, if well, we have to first check that the index is within bounds in haystack, right? So if index is greater or equal to hlen, then we return false, right? Or that is not true, but the characters do not match, right? So haystack dot char at index is not equal to needle dot char at of I, then we return false, right? And otherwise we say plus index, right? We are already incrementing the index of needle in the for loop, but we'll increment the index of haystack in here. And outside the for loop, we return true because all characters matched, right? So that's the helper, straightforward. And here, let's just calculate the difference between the two lengths. So int max start equal to, because the max starting index is difference between the two lengths, right? So haystack dot length minus needle dot length, and then we just run the loop. And index equal to 0, index is like less than, let's call this max index because the other variable is index. Yeah, and this is less or equal to max index, remember that. Plus plus index, and then we say if has substring at index in haystack at index do we have needle, right? If we do, then we return the index, right? And otherwise we return -1. We didn't find it anywhere, right? So yeah, I think that is pretty much it. Just want to run this, even though it's really straightforward, I always like to run it once. So let's run it on this one. And then we'll slightly change it just to make sure, right? So, okay. Okay. So if haystack was sad but sad, let's make this like dbu, right? Yeah. And needle was dbu. Then in that case, we basically say, hey, what is the difference in lengths? 9 minus 3, which is 6. So our max index is 6. So we have to go from 0 to 6. That makes sense. First thing is 0. At haystack, at index 0, do we have dbu? Here, this will be 0. And then we come here, we try to compare 3 characters, 0, 1, 2. 0 will fail because we know the index is within the bounds, the characters are different. So anyway, I think it's straightforward, but I just wanted to really run this a little bit in my head. Okay, let's run this now on the given examples there, test cases. Okay, cool. Now, in all such problems, I generally like to add test cases which will catch some off by one errors, right? So for example, let's say if there was an off by one error in our max index calculation, right? Then what will happen is we may not run this last one, right? So in that case, let's say this was sad but bad and this was bad, which means the needle we are finding is at the very last substring, right? Does it work in that case? Okay, so that worked. And similarly, if there is an off by one error at the beginning, which means we were, let's say, not looking at the first character in needle, so XAD, this should return -1, but if there was an off by one error somehow in reading that, it would be not -1. Okay, there you go. Okay, so now I'm going to try to submit and see how we do in a larger set of test cases and also our performance. Oh, that's pretty cool. So we have beat 100% of folks in runtime and we beat like 22% in memory, but this program does not use any extra, well, it uses constant extra memory is what I should say, not does not use any extra memory. So it's not really doesn't mean much. Okay, hopefully that was straightforward and helpful. If you're liking what I'm doing on this channel, please consider subscribing to the channel and hit that thumbs up button on the video. I'll see you guys next time. Thank you.